Hello everyone, good evening. Hello Mohi, hello Arif, hello Venkat. Good evening everyone. So today we are going to discuss atoms, nuclei and semiconductors. Both are not that easy chapter, okay? Question wise and concept wise, some of the concepts from the chapter nuclei are deleted, some of the concepts from the chapter semiconductors are also deleted. So the weightage wise, the chapter semiconductor used to be a high weightage chapter. It is now a medium weightage chapter where you can expect 2 to 3 questions. Atoms and nuclei combined together used to be 5 questions. Now last year there was 3 questions. This year maybe again combine these 2 chapters, you might get 3 to 4 questions max. Okay, semiconductor 2 to 3 questions, atoms and nuclei combined 3 to 4 questions. Total 6-7 questions you can get if you watch this lecture. Okay, and as I mentioned that PYQ is the way to understand an exam, what type of question comes from each chapter. So let's start. So first question, if the radius of the first Bohr orbit is r, then radius of the second Bohr orbit will be. So what is the radius of the second Bohr orbit? Namaste Guru Balaji, good evening Chandana. Hello Pooja, hello Sahana, hello Srinija. So what is the answer for this question? Quickly, what is the Bohr radius for nth orbit? Bohr radius for nth orbit. Something is happening to my phone, sorry. Okay, so again random answer, you are answering randomly, right? So Rn of nth orbit of Bohr's is n square r0. Okay, r0 is called Bohr's orbit or Bohr radius. Okay, so that is the ground state of any atom. So if first Bohr orbit is r, that is r0 is given here as r. First Bohr orbit means this is Bohr radius. Okay, so Bohr radius is r. Second orbit it will be 2 square into r, that will be 4r. Okay, so the nth Bohr orbit will be 4r. How do you think it will be 2 root 2r? Whatever you answer randomly, okay, maybe 4r, maybe 2r, out of these two you can guess, right? Yes, Chandana answered correctly. Pujit also answered correctly. Okay, so Deepak, Guru Balaji, you all have answered randomly. Vijay. Now next question, the ratio of area of first excited state to the ground state of orbit of hydrogen atom is. So ratio of area, just give me a second, my AC is not functioning. Okay, now the ratio of area of first excited state to the ground state of orbit of hydrogen atom is. So what is the again similar question, we know that area of what is the shape of the hydrogen orbit? Shape of the hydrogen orbit of electron is obviously this is the nucleus, and electrons are orbiting in a circular orbit. That is the Bohr's postulate. And if the orbit, say this is the radius of the orbit, okay, then this is a circle. So what will be the area of nth orbit? Area of nth orbit will be pi Rn square. Very simple. Okay, now it says that ground state of the orbit and first excited state. First excited state means n equals to 2 and ground state means n equals to 1. So A2 by A1 we have to find. Same concept that we have used for the previous question, that is pi into n into r naught whole square divided by pi into r naught whole square. Okay, so this can be written as pi into n square r naught whole square. Okay, so there is a n square r naught. So now let's put the values. Pi cancels, we get n to the power of 4 by 1. So n to the power of 4 means 2 to the power of 4 by 1. 2 to the power of 4 means 2 square into 2 square, that is 4 4s are 16 by 1. So it will be 16:1. Remember the order. It is not 1:16. It is not 1:16. It is 16:1. Why? Because first excited state to ground state. First excited state to ground state. So whenever you are solving a ratio based question, make sure whatever the order given in the question, first, second, same order has to be followed, first, second in the answer as well. Okay, there will be option exactly opposite to that in the option, so don't fall for the trap. You have to make sure your order, that is which one is first, which one is second, that has to be proper. Okay, otherwise you will lose. Even if you have solved the question correctly, because your order, you have opposite order of the question, you will lose marks. In alpha particle scattering experiment, if v is the initial velocity of the particle, then the distance of closest approach is small d. If the velocity is doubled, then the distance of the closest approach becomes. So how does distance of closest approach? Depends on the velocity. Okay. Ravindra is saying, sir, not clean board. The board is clean, bro. You check your resolution. You check your resolution, because I can see myself very clearly in my mobile. Okay, I am also checking my live, so that's how I am able to check your comments. So if you are not able to see the clean board, that means your resolution of the video that you are watching is not good. So please check the resolution. Maybe it is set on auto, so don't watch it on auto, go to advanced, at least watch in 720p. That should be sufficient. If you are watching in slightly slower internet speed, then 480p perhaps, but otherwise I recommend 1080 or 720p. Okay. In alpha particle scattering experiment, if v is the initial velocity, that means when the particle approaches the nucleus, alpha particle is approaching the nucleus. Okay, the distance that it approaches the closest, this is called distance of the closest approach. At this point, entire kinetic energy of the particle converts into potential energy. That means the distance of closest approach is actually proportional to v square, because higher the velocity, higher is the kinetic energy, and more close it will go near the nucleus. That means distance of closest approach is proportional to v square. So what is initially the distance was d. Now you have doubled the velocity, so d is equals to k v square. Vk is the constant. Now new distance of closest approach is k into 2v whole square. Okay, you have doubled the velocity, so that means it will be 4k v square, that is 4d. So new distance of closest approach will be 4 times I think I made some mistake. Yes. The mistake I have made is that higher the velocity, closer it will be. So it will be so higher the velocity, distance will be smaller. So it is inversely proportional. Sorry for that mistake. Okay, it will be inversely proportional to v square. So k upon v square. K upon v square. So d dash will be k upon 2v square. That is 1 by 4 k upon v square, that is d by 4. So if you increase the velocity, the distance will be 1/4. So yes, most of you have answered D. Gagandeep has spammed the chat with D. Nalin also, hello Nalin. Good evening. Deepak, no, C is incorrect. Gagandeep, don't spam capital, small, capital. I will read your answer once I have solved the question, don't worry. In the Rutherford's alpha particle scattering experiment, as the impact parameter increases, the scattering angle of the alpha particle. So impact parameter is different. What is impact parameter? Impact parameter is if the particle, suppose the alpha particle is going like this. So the distance between the, when it is crossing the nucleus, okay, the distance between the nucleus and the alpha particle is called impact parameter. Okay, this is not distance of closest approach, this is different. This is the perpendicular distance between the trajectory of the alpha particle and the nucleus. Okay, if it is going straight towards the nucleus, okay, then the impact parameter is 0. It is the in this case impact parameter is 0. And what happens when it goes straight towards the nucleus? It goes to a certain distance and then it repelled back, straight back. Okay, so the angle of scattering becomes 180 degrees. Okay, so smaller the impact parameter, higher is the angle of scattering. Smaller the impact parameter is, if it is 0, maximum angle of scattering 180 degrees is possible. Okay, if the impact parameter is slightly more than 0, then it will scatter like this, so angle of scattering will be more. Okay, so higher the impact parameter, smaller the impact parameter, higher will be the angle of scattering. So impact parameter is inversely proportional to angle of scattering. Okay, so if you impact parameter, if you increase the impact parameter, the angle of scattering decreases. If you increase the impact parameter, then the theta must decrease. Okay, so if you increase one quantity, other quantity will decrease because their relationship is inversely proportional. So option B is correct. Okay, Srinija is correct. Deekshita is, I think Deekshita answered D for the previous question. Srinija, Gagandeep are correct. Chandana is also correct. Deekshita, no. Venkatesh, no. C is not correct. Okay, so impact parameter is the parallel distance. So if you path, this is the trajectory of the particle, alpha particle. If there is no nucleus, it would have gone straight through this path. This is the path, trajectory. This is called trajectory. This is the nucleus, and the distance between this nucleus and the trajectory is called impact parameter. Just understand that. If the distance is closer, what will happen? It will scatter more because of the repulsion. Okay, alpha particle is positive, nucleus is also positive, so they will deflect by a more higher angle. Higher the angle, more is the angle of scattering. So remember that smaller the impact parameter, scattering angle is more. Okay, so if you increase the impact parameter, scattering angle will be less. That means increasing the impact parameter decreases the scattering angle. Very tricky language question. 3 energy levels of hydrogen atom and corresponding wavelength of the emitted radiation due to different electron transition are as shown. Okay, here we have 3 different transitions. I think the diagram is incorrect. Let me correct that slightly. So I think this is not lambda 2. Okay, this is not lambda 2. This portion is incorrect. Okay, so correct is this one is lambda 2. Okay, this one is lambda 2. Okay, this one is lambda 2. Now you solve this question. So what is the relationship between lambda 1, lambda 2 and lambda 3? Sorry. Again, small mistake. Extremely sorry. This one is lambda 2. Okay, So when the light jumps from E3 to E1 is lambda 1, when the light jumps from E2 to E1 is lambda 2, when light jumps from E3 to E2 is lambda 3. The arrow does not have any significance because it taking light and going to higher wavelength, or it is going from higher to lower, it is emitting the same wavelength. So this arrow has no significance. Only thing that you have to remember, when the light when the electron jumps from one level to another, it gives away certain frequency or certain light. Okay, that wavelength is given over here. Okay, now do not write that okay lambda 1 is equal to lambda 2 plus lambda 3. This kind of calculation is not correct. Okay, you have to simplify this. And how can you simplify? First of all, we have to use Bohr's theory. Bohr theory states that the energy of the radiant photon is equal to the difference in energy gap. Okay, difference in energy gap. So difference in energy gap means E1, E2 and E3. So E1 minus E2 equals to H nu 2. Okay, so this is the wavelength, so corresponding frequency say nu 2, so it will be E1 minus E2 is equal to H nu 2 or Hc by lambda 2. So E1 minus E2 equals to Hc by lambda 2, and E1 minus E3, E1 minus E3 equals to this light, that means it will be Hc by lambda 1. Okay, similarly E3 minus E2 equals to higher energy minus lower energy, higher energy minus lower energy, E2 minus E3. Okay, am I doing it correctly? So it will be higher energy minus lower energy, so it will be E3, E2 minus E1, E3 minus E1 and E3 minus E2 equals to Hc by lambda 3. So now we have found the relationship between all these. Now we have to simplify these and find. How to do that? Obviously, if you take equation number 1 and equation number 2, if you take equation number 1, this is equation number 1, this is equation number 2, and if you subtract 2 minus 1, what you will get? E3 minus E1 minus E2 minus E1 equals to Hc common 1 by lambda 1 plus 1 by lambda 2. Okay, that means if you see that, now simplify E3 minus E1 minus E2 plus E1 equals to Hc. Okay, lambda 1 lambda 2 lambda 1 plus lambda 2. Okay, so definitely E1 E2 cancel, so you get E3 minus E1 equal to Hc lambda 1 plus lambda 2 by lambda 1 lambda 2. Okay, now what is E3 minus E2? E3 minus E2 is Hc by lambda 3. So you get Hc by lambda 3 equals to Hc lambda 2 minus what was that? Lambda 1 plus lambda 2. I think sorry, this one will be minus. So lambda lambda 2 minus lambda 1 minus. Okay, it will be minus lambda 2 minus lambda 1. No. Lambda 1 minus lambda 2, sorry. 1 by lambda 1 minus 1 by lambda 2. Okay, so let's simplify that, and you will get Hc lambda 1 lambda 2. Okay, Okay, let's leave it here only. For now, let's leave it here because we do not know what we will get after solving this. So HC 1 by lambda 1 minus 1 by lambda 2. Leave it here. Okay, and then we will go to our next part. So here we will get 1 by lambda 1 minus 1 by lambda 2. So HC cancels, we get 1 by lambda 3 equals to 1 by lambda 1 minus 1 by lambda 2. Okay, so it is actually inversely related. Now let's see what we can calculate from here. Obviously this relation is incorrect. Let's try to find lambda 1. Let's try to find lambda 1. So 1 by lambda 1 equals to 1 by lambda 3 plus 1 by lambda 2. That is lambda 2 lambda 3 into lambda 2 plus lambda 3, or lambda 1 equals to lambda 2 lambda 3 okay, lambda 1 equals to lambda 2 lambda 3 by lambda 2 plus lambda 3. Okay, so if you see that, correct answer coming out to be option A. Okay, having the knowledge that this can give me 1 by lambda 2 plus 1 by lambda 3, I have chosen lambda 1, and that's how we got the answer. Okay, so this is the correct answer. Remember, wavelengths cannot be added directly, it can be added reciprocally. That you should remember. Okay, now next, in accordance with Bohr's model, let's see who can answer. Sir, time consuming, not solvable in 1 minute. Yes, some of the questions are time consuming. Remember that I always tell you there are some questions which can be solved in 10-20 seconds. There are some questions which can be solved in 1 to 2 minutes. Okay, there are some questions which can be solved 5 to 10 minutes. Okay, so there are different categories of the questions. So 10 to 20 seconds questions, you save time. 1 to 2 minute question, you use that time to solve those questions. 5 to 10 minutes level of questions, you skip those questions. You guess the answer and skip. Okay, so that's how you should prepare for your KCET exam, because you cannot answer 5-10 minute long question in the KCET exam, but that will take a very long time. 2-3 minutes, okay, 2 minutes, 3 minute question you can solve. Okay, that question, but because obviously I am trying to explain, that's why I am doing all the mathematics. If I am starting, I might start with this formula directly, but if I write this formula, you might say, sir, how this formula came? Okay, so having the knowledge that this is the formula in terms of wavelength, and in case of frequencies, frequency can be added. Frequency can be added. So frequency can be added. In terms of wavelength, inversely it will be it can be done. Okay, so wavelengths will be inversely proportional, inversely added. Frequency is directly added. If you know this formula, then it is less than 1 minute problem as well. But again, if you don't know it, if you are just knowing the basics, which most of us are actually do, okay, all shortcuts, all small formulas, it is difficult to remember. So in that case, you have to solve it 2-3 minutes. That 2-3 minutes you can save from 20-30 second questions and invest. Okay, that's how you should proceed. More formulas, more concepts you can remember at once, more quickly you can solve the question. Okay, and more practice that you have done. Practice is also very, very important. In accordance with Bohr's model, the quantum number that characterizes the Earth's revolution around the Sun in an orbit of radius 1.5 into 10 to the power of 11 meter with orbital speed of 3 into 10 to the power of 4 meter per second is, given mass of Earth is 6 into 10 to the power of 24 kg. Okay, so Bohr's atomic model, they have asked you what is the quantum number. Now if you remember that, what is the Bohr's atomic model? Bohr's atomic model says that the angular momentum of the electron must be equals to integer multiple of nh by 2 pi. Okay, so every angular momentum must be integer multiple of nh by 2 pi. That is the Bohr's postulate. So what is L here? L given for a, now here instead of atom we have our planet Earth, which is orbiting around Sun. So radius is given, mass of Earth is given, okay, radius of Earth is given, approximately circular we have assumed, okay, radius is given, orbital speed is given, and mass is given. So that means we require all of them. Angular speed is mvr, actually it is m omega, but omega is r into v, so it will be mvr. Angular momentum for Earth will be mvr. Okay, so what is m? With respect to the distance, size of the Earth is point mass, that's why we are using mvr, not I omega, I into vr. Okay, so that's why we are using mvr, because with respect to the distance from the sun, size of our planet is almost point mass. Okay, so mass of the Earth is 6 into 10 to the power of 24. Velocity, orbital velocity is 3 into 10 to the power of 4. Everything is given in SI unit, so no need to change any units. And radius is given 1.5 into 10 to the power of 11. So this is the angular momentum, and that should be equals to the formula, which is n into h is 6.62 into 10 to the power of minus 34 divided by 2 pi. Okay, so thus we get 6 into 3 into 1.5 into 10 to the power of 24 plus 4, 28. 28 plus 11 is 39 divided into 2 pi divided by 6.62 into 10 to the power of minus 34. Okay, so as you can see, this question is not about the magnitude, it's more about 10 to the power of value calculation. It's more about 10 to the power of value calculation. If you calculate the closest 10 to the power of value, your problem will be solved. Okay, and that is equals to n. So if you simplify these two equations, you will get this. So 6.62 can approximately be cancelled with this 6. Okay, approximately, or rather I will not cancel this 6, I will take this 2 pi and I will cancel it. 2 pi means what? 2 pi means 2 into 3.14, which is 6.28. So 6.28 and 6.62 are very close, so let's cancel that. So 2 pi and 6.62 are cancelled. Now let's see. So it will be 18 and 1.5. 1.5 means 27. 27 into 10 to the power of 39 minus 34. So 39 plus 34, that will be equals to 27 into 10 to the power of 73, approximately very close. Okay, so if you see the answer, if you take one more decimal into the calculation, it will be 2.7 into 10 to the power of 74. So if you just had calculated the 10 to the power of values, and if you have taken the closest 10 to the power of values, you could have solved it. You don't need to solve everything with proper values. Okay, only calculating proper 10 to the power of value, which is 73, 74, you realize that the only closest option is 74, not 64. Okay, it will no longer nowhere close to be 64, so you can easily safely say that the correct answer is this. So this is how you should solve some questions. Some cases it might be very, very handy, right? So who got correct answer? Option C is correct, not A. Okay, Venkatesh, Nalin, Chetan. Hi, 2008 Shravya Shetty. Hello, Shravya Shetty. An electron is revolving in its Bohr orbit having Bohr radius 5.529 angstrom. Then the radius of the third orbit is. So how to calculate the third orbit? So Bohr radius for ground state. Bohr radius means ground state is given. So R naught is given, which is 0.529 angstrom. So what is the radius for third orbit? It is very simple, 3 square R naught. Okay, n square R naught. So n is 3, so 9 into 0.529. Again we will approximate 0.529 as only 0.5. 0.5 means it will be close to 4.5, more than 4.5, 4.5 angstrom. Okay, so if you see all the options, closest option is this one, 4.7. Okay, we have calculated 4.5, our answer we got 4.7 because we ignored this 2,9 term. So that is very much acceptable because you are not using any calculator. Hello Chetan, good evening. Okay, so option A is correct, Stravya. Okay, not option D. Chetan, option D is incorrect. Okay, it is 4496 angstrom. It is 4496 angstrom. Okay, that is much bigger than this value. 4.5, here it is 4496. How can this be close? Okay, even if it is nanometer, that means it will be 10 to the power of 9. That means if you take it in angstrom, it will be 449.6. That is also very huge. So you cannot even consider that. The radius of hydrogen atom in the ground state is another similar question. Now solve this. So radius of hydrogen atom in the ground state R0 is 0.53. So this is also a very common pattern question in KCET. Okay, 21, 22 both year this question came. After collision with an electron, it is found to have a radius of 2.12 angstrom. So the radius n is 2.12 angstrom. Okay, the principal quantum number n of the final state. What is the principal quantum number? So Rn equals to n square R0. Okay, Rn equals to n square R0. So from here we can say that Rn value is given 2.12. So 2.12 equals to n square into 0.53. So n square equals to 2.12 divided by 0.53. So it will be 4. Okay, 2 and 0.5. So again we will take the approximation. 2 by 0.5 is 4. Okay, it is 4. So 4 is the closest value. So n will be 2. So the Bohr orbit, this is for n equals to 2. This is for n equals to 2. Now next, energy of an electron in the second orbit of hydrogen atom is E2. The energy of electron in the third orbit of helium will be. So again, I think this question is slightly out of syllabus, but you can solve it. So energy of electron in the second orbit of hydrogen is E2. So energy of electron in the second orbit of hydrogen is E2, and what will be the energy of electron in the third orbit of hydrogen? Okay, so energy, ground state energy, if suppose ground state energy is E0, so energy will be proportional to minus E0 by n square. Okay, energy is proportional to E0 by n square. So E0 is the ground state energy, and if you multiply Z cube, I think Z cube, no, Z square also, it will also be square, Z square. Z is the number of positive charges in the nucleus. Z is the number of positive charges in the nucleus. Okay, so E0 by n square for hydrogen, Z equals to 1. For hydrogen, Z equals to 1. For helium plus, it will be Z equals to plus 2. So the same formula will be applicable, E0 square by n square, but here Z will be equals to 2. Now in this case it is only equals to 2 for hydrogen. This is for hydrogen, so let's put that. It will be minus E0 by 4. Minus E0 by 4. Z equals to 1. Z equals to 1. Now what about for helium? For helium, this value will be minus E0. E0 is fixed. It is generally minus 13.6. Okay, minus 13.6. So it will be minus E0 by 3 square into 2 square. So it will be minus 4 by 9 E0. Okay, so it will be 4 by 9, I think where I made a mistake. 4 by 9 E naught. So this is 4 by 9 E naught. We have to replace E naught from this equation. Okay, we have to replace, because our answer cannot be based on E naught. Our answer has to be based on E2. So from here we say that E naught equals to minus 4 E2. E naught equals to minus 4 E2. So we have to simplify, we have to put that here, minus 4 by 9 into minus 4 E2. So it will be 16 by 9 E2. 16 by 9 E2. So correct answer will be option B. Okay, correct answer will be option B. Again, this is slightly tricky. This exact formula is not there in your NCERT, but individually these two formulas are there. You can combine these two formulas to get this formula. That's why this kind of question might still be asked. Okay, how energy is related with the atomic number is given, how the energy is related to orbit number is also given. Now next, a beam of fast moving, yes, so option B was correct. A beam of fast moving alpha particles were directed towards a thin film of gold. The parts A, B and C of the transmitted and reflected beams corresponding to incident parts A, B and C of the beam are shown in the adjoining diagram. The number of alpha particles in A dash will be minimum and B dash will be maximum. So what happens is that a lot of alpha particle is coming towards the gold foil. Okay, and after the observation, what you have observed, some particles are going straight, some particles are scattering at an angle, and some particles are directly reversing their path and going by an angle of 180 degrees. So they saying that how many particles will go straight, how many particles will scatter, or how many particle will invert back. We know that 90% of the atoms actually travel straight. Okay, and 99% of the atoms actually travel straight, and less than 1%, around 1%, they scatter by an angle. Okay, and 1 in 12,000 or 1 in 8,000 they move by a more than angle of 90 degrees, and 1 in 12,000 they directly comes back. Okay, so 1 in 12,000 is this, 99%, that is about 11,050, right, that they go straight, some 40-45 they go at some angle, and less than 1 go straight back. So A dash is maximum will go flat, go straight. That's why Rutherford concluded that most of the atom is empty. Okay, and there is a concentrated part of the mass, so that mass he called nucleus. So this will be the maximum and B dash will be minimum. So A dash will be maximum and B dash will be minimum. Right, option D is correct. Yes, Skylar, Stravya, Deekshita, Usha, all of you are correct. Okay, now next question. Match the following types of nuclei with examples shown. Okay, so here are few examples given: isotopes, isobar, isotones. You have to match the question. Give me 2 minutes. I need to fill my water bottle. I am thirsty and my bottle is empty. So please find the answer and mention the answer in the comment by the time I come back. Only 2 minutes time. Okay, let's see. C or B, not sure. Someone is saying B. Ushacharya is saying B. Let's see. So let us understand what are isotopes, isobars, isotones, so that you never forget in the exam. Isotope means same atom. Same atom means symbols are same. Okay, so isotopes are same atom, only the number of neutrons are different. Okay, so that means here if you see these two are having same symbols, so they must be isotopes. Isotopes must have same symbols. Okay, so A must be matched with 3. So B and C, someone is saying B and C. Out of these two, not sure, is correct. Next is isobars. Okay, isobar means they have same mass number. Bar means same mass number. Okay, isobar means mass number is same. Okay, isobar means this value is same. Okay, mass number is same. And isotones is slightly deeper. Isotones, you need to do some calculations to find out, that is number of neutrons. Isotone means number of neutrons. This one you cannot identify directly, you have to calculate it. That is A minus Z, mass number minus atomic number. Okay, so if you see that here 18 minus 8 is 10, 19 minus 9 is also 10. So both of them have same neutron numbers. Okay, so number of neutrons are same. So that means isotone is 2. Isotone is 2, isobar is 1. Whereas isotope is here 3. So 3, 2, 1. 3, 2, 1, option B is correct. Option B is correct. Yes, so Chetan, no, C is not correct. No, C is not correct. 3, 1, 2. Sorry, 3, 1, 2. Sorry, 3, 1, 2. 3, 1, 2. Yes, 3, 1, 2. Okay, so 3, 1, 2 is correct. So option C is correct. So just remember in your head, isotopes, same atoms. Okay, you don't need to look for anything else. Isotopes, same atoms. Isobar, mass number, one value are same. If the value which is at the top are same, they are isobars. Isotone means you have to calculate. Okay, isotones are not easy, you have to calculate, find the difference. If the difference is same, that is isotones. Okay, now you should be able to remember it clearly. Which of the following statements is incorrect with reference to nuclear force? Okay, nuclear force becomes repulsive for nucleon distance less than 0.8 femtometer. You have to find the incorrect statement. Nuclear force becomes repulsive. So if you have remembered the potential energy graph, this is the potential energy graph. So this is the 0.8 femtometer. So this distance is 0.8 femtometer. So 0.8 femtometer means if the distance is less than this, the potential energy is positive. That means the force is repulsive. Okay, this zone represents the nuclear force is repulsive. This zone represents nuclear force is attractive. Okay, generally it runs from 0.8 femtometer to around 2 femtometer. Okay, this is approximately 0.8 to 2 femtometer. Okay, and beyond that the nuclear force becomes 0. Nuclear force becomes 0. Okay, nuclear force is always attractive is incorrect. Nuclear force always attractive is incorrect. This is the incorrect statement. I know option B is correct. Let's see the other options. Potential energy is minimum if the separation between the nucleons is 0.8 femtometer. So 0.8 femtometer is nuclear potential energy is minimum. Yes, that is correct. Nuclear force becomes attractive for nucleon distance larger than 0.8 femtometer. So if it is larger than 0.8 femtometer, this is positive. slowly, even though it becomes 0 afterwards, but still it is positive value, not negative. Okay, so that means it is attractive for distances greater than 0.8. So only incorrect statement is nuclear force is always attractive. That is incorrect. Okay, now let's move on to the next question. So how many of you have answered? Yes. Yes. So here incorrect is correct. So sometimes false is correct, incorrect is correct, right? So make sure you understand, read question, because incorrect, false, which of the following is not correct, which of the following is incorrect, which of the following is false, which of the following is not true. Those kind of questions can be confusing. So make sure you underline when you read such questions. Consider the nuclear fission reaction of 01N plus 23592U that gives you 14456 barium plus 8936 krypton plus 3 neutrons. Assuming the kinetic energy is carried away by the first neutrons only. So these are the fast neutrons. These are called fast neutrons, okay, because they move very fast. Fast neutrons only, and the total binding energies of U, barium and krypton to be 1800, 1200 and 780 MeV respectively. The average kinetic energy carried by each fast neutron is very easy question. Okay, you can ignore the energy of this neutron. This is slow neutron. Okay, this generally do not have any energy. So the binding energy of this one is given. That is given as 1800. Okay, binding energy of this one is given 1200, and binding energy of this one is given as 780. So this is the mother product, this is the mother, that is the uranium, and these are the daughter. It is called daughter. Daughter means the product. Products are called daughter nucleus. Okay, so we know that binding energy increases in nuclear fission. So what is the total binding energy here? Total binding energy is 1980. Total binding energy is 1980. Okay, and I have not made any mistake. Yes. Now what is the binding energy of the mother nucleus? Binding energy of the mother nucleus is 1800. So the binding energy, the energy that is being given away, energy that is being produced in this process is 180 MeV. This is the energy which is produced in the process, 180 MeV. Okay, now average kinetic energy carried by each fast neutron will be 180 divided by 3, that is 60 MeV. So energy, average kinetic energy carried away by each fast neutron is 60 MeV. Now here the values given in the options are not properly correct. Total binding energies are given also. Okay, so the binding energy per nucleon is not required. So binding energy per first neutron is 60 MeV, which is not given in any of the options. If you want to guess our option, that should be the closest option, which is 84. This question should be a bonus question in 24. Okay. Are we allowed to take the KCET question paper home? Yes, Shrija, you can take. See, today if I see anyone is discussing anything other than study, no, I will block them. Okay, enough is enough. I don't require any weed in my class. Okay, if you come, you have came to chat and discuss rubbish, I will block you. Straight away block. The ratio of volume of 27A nucleus to its surface area given R naught is 1.2 into 10 to the power of minus 15 meter. Okay, so radius, ratio of volume to its surface area, very interesting. So what is the, suppose the radius is given by R. R is given as the atomic number, the mass number to the power 1/3 into a constant R naught. Okay, R naught value is given in the question. This is the radius of any atom, nucleus. Radius of the nucleus is given by this value. Now what is the volume? Nucleus, what is the shape of the nucleus? Nucleus is spherical. Okay, nucleus is spherical, so volume must be 4/3 pi r cube. Okay, what is the surface area? Surface area is 4 pi r square. So what is the ratio between volume and surface area? So ratio of volume by surface area is 4/3 pi r cube by 4 pi r square. So this is pi cancels, 4 cancels, r square r, one of the r gets cancelled, so you get r by 3. So the ratio of volume to surface area is r by 3. Now what is r? R is a to the power 1/3 r naught by 3. And what is a to the power of 1/3? A to the power of 1/3 is 27 to the power 1/3 r cube. 1 by 3. So 27 to the power 1/3 means obviously 3 r naught by 3, which is r naught. So the answer will be same as this, 1.2 into 10 to the power of minus 15. So option D is correct. Okay, this is, now remember that you cannot ignore this 3. Okay, you cannot ignore this 3. In some cases maybe you will get an answer where they will give you 64. So in case of 64 it will be 4/3 of this value. So you have to calculate this thing. You need to remember the ratio of volume to surface area is radius divided by 3. Radius is a to the power of 1/3 r naught. Okay, now next question. In the following equation representing beta decay, the number of neutrons in the nucleus X is. So they are telling you a beta decay. Don't worry, what is beta decay? Beta decay is basically an electron which gives rise to a -1 value. Now it is coming from the nucleus because a neutron is breaking into a proton and an electron. Okay, a neutron is breaking into proton and electron. This is called beta decay. So what happens when a nucleus undergoes beta decay? Its mass number remains same. Okay, but its atomic number increases by 1. Okay, so when one atom undergoes beta particle transformation, okay, so the X will have, so beta here bismuth 21083 undergoes beta decay. That means X will have 210, same, this number will remain same, the below number will increase to 84. The below number will be increased to 84. So what is the number of neutron? Number of neutron will be 210 minus 84, which is 130, 126. This will be 126. Okay, 126 is the answer. Not 127, not 125, exactly 126. Okay, clear? Next, binding energy of nitrogen nucleus given mass of nitrogen is given. Okay, so this requires a little bit of knowledge that binding energy of the mass defect, you have to calculate the mass defect, and then you have to calculate the binding energy. We have a formula for that. How to calculate mass defect? You need to know the mass of the proton, mass of the neutron. Okay, so mass of proton is approximately 1.78. okay, and mass of neutron is approximately 1.88. exactly. You can take the value 1.007 approximately, you can take that value. Okay, and this also you can take 1.008. approximately you can take. Okay, so this is the values that you need to know to solve such questions. So how many protons are there? So number of protons in nitrogen is 7, number of neutron is also 7. 7, 14, so equally distributed. Easy question. So let's calculate, and from here you have to subtract the given mass. Okay, so let's calculate the mass of the proton and mass of the neutrons, total mass. It generally requires a calculator, but we can solve it without using calculator as well. Okay, so mass of proton is as I mentioned, mass of proton is 1.007. we have to find the number of neutron, number of protons into number of neutrons. Okay, so what so 7 into 1.007, exact value you don't need. 7 into 1.008 minus 14.003. okay, I am even ignoring this part, so it will be 1.049 plus 7.049 plus 7.056, right? 7 8 is 56 minus 14.003, so it will be 14.49 plus 56 is 105, so it will be 105 minus 14.003. so what is the mass defect? That will be 0.102. so mass defect is 0.102 U. Mass defect is 0.102 U. Now 1 U approximately equals to 930 MeV. This conversion again you need to remember. These are the conversion factors you need to remember. Now let's multiply. So 0.102 U equals to how much MeV? It will be 0.102 into 930. Okay, so that will be 100, 900, approximately 1000. If I take approximately 1000 means 102. Let me take one thing. 1.02 into 93, so it will be approximately 90. Okay, approximately 90 point something MeV. Okay, 90 point something MeV. So if you see the closest answer, because we have reduced the values a lot, okay, the closest answer will be not 85 but 104. Why? Because every stage we have reduced the values. Every stage we have reduced the values. If you have taken all the values correctly, it would be much more than 90 MeV. Okay, even it is more than 90 MeV here as well. Okay, it is approximately 93.6 MeV. Okay, if approximately it is 93.6 MeV. So if you take exact values of all the mass defects, you will get around 104.7. Even that value is slightly stretched, it will come around 100, Okay, they have given slightly more accurate values. If you have to take all the values accurately and do the calculation exactly accurate for this also, then only you will get this 104.7. Otherwise the rough answer will be around 100, and that means our correct answer is not 85 but 104. Okay. Yes, B is the answer. Nuclear reactor delivers a power of 10 to the power of 9 watt. The amount of fuel consumed by the reactor in 1 hour is. So the power consumed by the fuel, the reactor is 10 to the power of 9 watt, and they ask you the fuel consumed in 1 hour. Okay, so the power is 10 to the power of 9 watt. Okay, what is watt? Watt means 10 to the power of 9 joules per second. Okay, so how much energy you require in 1 hour? You require power into time. Time means 60 minutes into 60 seconds. Okay, so this much energy you require in joules. So that means 3600 into 10 to the power of 9 joules energy you require in 1 hour to get this much power. Okay, now from where we will get the energy? By burning nuclear mass or nuclear fuel, that is Einstein's mass energy equation, which says that mc square is the energy. This is the source of energy. Okay, so mc square, m into 3 into 10 to the power of 8 whole square equals to 3600 into 10 to the power of 9. Okay, or m equals to 3600 into 10 to the power of 9 divided by 9 into 10 to the power of 16. So this square, okay, m equals to this divided by this. So 3 into 10 to the power of 8 whole square is 9 into 10 to the power of 16. Okay, 4 9s are 3600, so it will be 400. So 400 into 10 to the power of minus 7 kg. It will be in kilograms, okay, because we are using everything in SI, that will be in kilograms. So that means 4 into 10 to the power of minus 5 kilograms, or 0.04 into 10 to the power of minus 3 kilograms. Now 10 to the power of minus 3 kilograms can be written as grams. So 0.04 gram is required. So only burning 0.04 grams, okay, 40 milligrams, or no, not even 40 milligram, 0.4 milligrams, okay, you are going to get a huge amount of 4 milligrams, I think. You are going to get this much amount of energy. That is the power of mass. If you can destroy mass, you get a huge amount of energy. Which graph in the following diagram correctly represents the potential energy of a pair of nucleons as a function of their separation? Which of the following graph represents the potential energy of the nucleons between based on their separation? Now if you see that there are 3 patterns same, this one, this one, this one. So out of the 3 same patterns, one of them must be the answer. Obviously odd man out, this cannot be the answer, okay, because this is very unique, that cannot be the answer. So that means these 3 has to be, one of them has to be the answer. What is the difference between them? Difference is in the scale. So this one is kilo electron volt, this is in this is electron volt, this is mega electron volt. Kilo, electron, mega. So obviously the potential energy between 2 nucleons is of the order of mega electron volt. So correct answer will be D. Okay, there is one more guess. So even though this pattern is wrong, the scale is correct. So check which of the options have same scale and same pattern. So same pattern is this one, same unit is this one. So this must be the correct answer. Okay, so this is also a way to guess. So this is basically the potential energy graph for nucleons. Now straight from your NCERT textbook. Two protons are kept at a separation of 10 nanometer. Let Fn and Fb be the nuclear force and the electromagnetic force between them. Which is correct? Answer this. Answer this. Last one is done. Answer this one. Okay, so here let Fn and F be the nuclear force and the distance given here is 10 nanometer. We know that nuclear force is strong when the distance between 0.8 to 2 fermion. What is 1 fermion or 1 Fermi? That is 10 to the power of minus 15, okay, meter. Whereas 1 nanometer is only 10 to the power of minus 9 meter. So this distance is much smaller compared to this. This distance is much smaller compared to this. So by this distance, the nuclear force is almost zero. Nuclear force is negligible compared to electric force. So electric force will be much stronger than that of nuclear force. Okay, so Fe is greater than Fn is the correct answer. Now next question, during a beta decay, neutron, so I think most of you have answered correctly. Option D is correct. In the previous question, most of you have answered correctly, not option A, option D was correct. Now answer this. During a beta decay, a neutron in the nucleus decays emitting an electron. I think you are already answered this question. Kavna, what is your point? Why you are deleting your chats? A neutron in the nucleus decays emitting an electron. A proton in the nucleus decays by emitting an electron. An atomic electron is ejected. An electron which is already present within the nucleus is ejected. These two options are not correct. Okay, proton is more stable than neutron. Neutron which decays into a proton and an electron. This electron is emitted. Okay, this is beta decay. Okay, beta decay means unstable neutron, it becomes proton by emitting electron. Okay, so that's why this is called beta decay. So this is the correct answer, option A. Chetan, no, not D. Strabya answered correctly, option A. Right? Now let's move on to the next chapter, semiconductors. So from this chapter, if you are solving the previous year paper, if you are solving questions based on logic gates, okay, or Zener diodes, or say biasing voltages, etc., Zener diode related questions basically, and photodiode, those questions are not part of the syllabus, so you can ignore those concepts. So let's see one question from 25. The range of electrical conductivity sigma and resistivity rho for metals among the following is. So electrical conductivity and resistivity for metals, not semiconductors but metals. So even though the chapter is semiconductor, they are asking question about metals. Okay, so remember that metals have a very high conductivity and very low resistivity. So for metals, conductivity is very high, resistivity is very low. So from the given option, which one has the very high conductivity and very low resistivity? Do not mark this, even though they have given in the question sigma and rho. In the option, rho and sigma order is given. Ohm is order of resistivity. Okay, Siemens is the order of conductivity. Okay, in opposite of ohm is called Siemens, which is the unit of conductivity. So high conductivity means 10 to the power of values will be very high. 10 to the power values will be very, very high. So if you see that here 10 to the power value is high, higher than all the other options, higher than all the other options. So 10 to the power of 2 to 10 to the power of 8, whereas resistivity here is minus to minus. So for metals, resistivity will be power negative, conductivity will be power positive and high. Semiconductors, they both have both ranges, plus and minus. Okay, semiconductors have both ranges, plus and minus. Insulators have, again, rho will be positive, sigma will be negative. Rho will be positive, sigma will be negative. So that is how you identify. This one is does not make any sense. This is also an insulator, but better insulator is this one. Okay, so this is the answer for the question. Okay, how to identify? Conductivity high, resistivity low, that is metals. Conductivity is low, resistivity is very high, that is insulators. Semiconductor is between plus and minus. Both values will have plus and minus. I think once they have given ohm centimeter unit to confuse you, but that also can be solvable. Which of the following statements is correct for n-type semiconductor? The donor energy level lies at the halfway mark of the forbidden energy gap. Okay, the donor energy level does not exist. The donor energy level lies just below the bottom of the conduction band. The donor energy level lies closely above the top of the valence band. So what is the meaning of n-type? N-type means it is a negative type. That means it gives electron to the conduction band. Okay, so if you plot the band diagram, if you plot the band diagram, you will see that this is the valence band, which is at the bottom, and the next higher energy band is the conduction band. Okay, now if you add external impurity such that there is a new level develops which have lot of extra electrons, these electrons it supplies to the conduction band, this energy gap is less than 0.01 electron volt. Okay, then it is called n-type semiconductor, and this is called donor level. This is donor level. Okay, this is for n-type. This diagram you have practiced during your PU exam. If you have not practiced, go and check your NCERT textbook. Very common. Donor level, acceptor level. Donor level is for n-type, acceptor level is for p-type. Acceptor level is just above the valence band. Donor level is just below the conduction band. Okay. Next, 3 circuits shown in the figure contains 2 ideal diodes D1 and D2. If a cell of EMF 3 volt and negligible internal resistance is connected as shown, then the current through 70 ohm resistance in ampere is. Okay, so you have to find the current through this ohm resistance. Now if you see that here the diode is ideal, so voltage drop across the diode is 0. Okay, now what? Now if you see that this is positive, this is negative. So this is p side, this is n side, this is n side, this is p side. So this diode is forward biased, this diode is forward biased, whereas the other diode is reverse biased. So if positive is connected to positive, negative is connected to negative, we say the diode is forward biased. But if negative is connected to positive, negative and positive of the diode is connected to negative of the battery, then the diode is said to be reverse bias. So reverse bias means no current passes through this. This diode is disconnected from the circuit. So actual circuit here is actually, simplify, if you simplify this, this is just a 30 ohm resistance, this one, and connected with a cell. This one is 70 ohm. Okay, this is 3 volt. This is the simplified circuit. Very simple. So total resistance 30 plus 70. Total resistance is 30 plus 70. That is 100 ohm. So what is current? current is V by R, that is 3 by 100, that is 0.03 ampere. Same current will pass through this one and this one as well. So 0.03 ampere is correct answer. Yes, B is correct. Chetana, Malik, Nayak, okay, Chetan, Stravya, Chandana, everyone is correct. Okay, now let's move on to next question. A PN junction diode is connected to a battery of 5.7 volt in series with a resistance of 5 kilo ohm. This is kilo ohm. Okay, ohm symbol is somehow got misplaced, such that it is forward biased. If the barrier potential of the diode is 0.7 volt, it is a silicon diode. Silicon diode has a 0.7 volt barrier potential. Neglecting the diode resistance, the current in the diode is. So the EMF that you supply, suppose this is the diode. Okay. The supplied EMF is 5.7. The barrier potential is 0.7. Barrier potential is opposite to that of the applied potential. So the net effective voltage is the potential that you have applied minus barrier potential, that is 5 volt. So 5 volt is the barrier net effective voltage. The resistance here is 5 kilo ohm, that is 5000 ohm. So what is the current here? The current is very simple, V upon R, that is 5 divided by 1000, that is 5 milliampere. Have I made any mistake? It is 5 by not 1000. My brain is not functioning properly today. So it is 5 by 5000. So it is 0.01 or 1 milliampere or 1 milliampere. 1 milliampere. So correct answer is again option B. Yes. Sir, pray for everyone's good result tomorrow. Extreme. All the best. Tomorrow will be your result. Okay. And I hope everyone gets 90% and plus. Okay. And obviously everyone's result will be great. Don't worry too much about result. When it comes, it will come, and immediately after the results are out, I can guarantee the servers will be down. You need to wait for 1 or 2 hours. Okay, the board will give some statement saying that we had a server crash, we have to fix it, because immediately after the result out, everyone goes and tries searching the result. Okay, so server crashes. If 2-3 lakh students, immediately after that, if they go and try to search it, obviously it will crash. It is norm. It was norm when I was a student. It is norm nowadays also. Okay. In fact, when I was a student, the bandwidth, the internet speed was not so high, and we have to go to internet cafes because internet was not common to our households. Everyone, okay, internet was very expensive. You have to visit the cafe, okay, and check your results. It is mobile phones was not there. Normal mobile phone was there, not the smartphones. So that's how we developed. From that generation, we came to this generation, right? The upper level of valence band and lower level of conduction band overlap in the case of silicon, copper, carbon, germanium. Answer this. Option B, yes. This is a semiconductor. Okay, so it does not overlap for semiconductor. This is a metal, that is a conductor. Normal carbon is insulator, and germanium is also semiconductor. Okay, so this question is basically identify which of the following. Instead of this, if they ask which of the following is a metal, please identify So you will say that, okay, I know copper is a metal, so that is the question. So basically it is not about valence band and conduction band overlap, it is basically which of the following is a metal, that's it. Okay, instead of asking metal semiconductor, they give you examples of metals and semiconductors. Depletion region in an unbiased semiconductor diode is a region consisting of both free and electrons and holes, neither free electrons nor holes, only free electrons, only holes. So what is the correct answer for this question? Yes. So yes, correct answer is neither free electrons nor holes. Okay, again the Shreyas is came. Shreyas, do not discuss. Narendra, whatever is your name, Shisharao or Narendra. Okay. Waiting for second attempt, Tanjiro, it depends. Okay, because first of all the preparations that you have in your first exam, okay, there you have not studied everything. You have studied portions, you have studied the important questions, you have studied the questions which you expect will come. So the predictions I have made in first exam, 90% came from that. Okay, 90% including numericals, including MCQs, everything was common. Okay, I will not be able to make that prediction for paper 2. Paper 1, you can make some level of prediction. Paper 2 is completely unpredictable. It can have 70% of the same paper repeated. Okay, it can have complete 100% new questions. Okay, it will come from the important questions only. But trust me, tell me by touching your heart, how many important questions you have studied in the first exam? You have done cut short in that. You have done cut short in the numerical practice as well. That's why you are thinking about preparing for the second exam. Okay, so I predicted numerical questions as well in the first paper. Okay, whatever I have done in the numerical question, exact same question came. Exact same question came in the exam. Now I will not be able to do that in the paper 2. It is not possible. Okay, paper 1 is somewhat predictable, paper 2 is completely unpredictable. But if your marks are below certain threshold, say after even including practicals, if you are getting 70, 80, 60, 70 marks, you should try an attempt. But if your score is 80 plus, you should not think about it. Okay, if your score is say 60, 70, then you might think, okay, I scored only 30 marks or 35, 32 marks, 33 marks in my theory paper, I should try and improve it. If your theory marks are 50 plus, you should not attempt it. If your theory marks is below 45 and below, then you should think about it. Okay, because there is no harm, your better marks will be staying with you. Between the two exams, whatever score is better, that will stay with you. So that's why I say, if you think, okay, I will work hard, I am confident, I will give my best, then only you should attempt it. Okay, but again, you have to study more. KCET exams is coming. KCET exam will happen faster before second attempt, so you have to prepare for KCET exam. Okay, I think the second exam schedule, whichever available previously, now changed. You can go and check it out. I am not sure. When I last checked, the second schedule was withheld by the board. So they are saying that we will release the schedule because it was clashing with the KCET exam. So I don't think it will happen before KCET exam. It will happen after KCET exam. So you have to consider that as well. When a PN junction diode is in forward bias, which type of charge carriers flows in the connecting wire? I will block you, Narendra, if you keep talking about anything else, and if you ask me, sir, please explain the question, and in the meantime you will discuss in the chat, I am not going to allow that. Okay, I will explain the question, anyone else, not you. Okay, clear? When is Comet KC 30 days crash course today? Gargi, the crash course orientation already happened. You may have missed it. Orientation was there at 3. Okay, it is already happened. If you have the login details, go to your login page, use the user ID and password, and go to your dashboard. From the dashboard, click on Smart Class, and in the Smart Class, you will be able to see the recorded session where we have explained how to access the course properly. You can go check that out. Okay, Comet K 30-day crash course orientation already happened. It will also be uploaded on YouTube. Don't worry, if you missed there, you can check here also. It will also be uploaded on YouTube channel very soon. Okay, when a PN junction diode is in forward bias, which type of charge carriers flows in the connecting wire? Ions, protons, holes, free electrons. Who can answer this? Yes. Yes, I know tomorrow is the result. So it will be free electrons. Free electrons always, no matter diode, no matter whatever device it is, in the conductor, inside the conductor, only electrons can flow. Electrons cannot, holes cannot come out from the diode into the conductor. Okay, holes cannot come out from the diode to the conductor. Diode, the holes will be restricted only inside the diode. Okay, and only electrons will be conducted in the conductor. Okay, inside the diode, holes, electrons both carry current, but outside the diode, only electrons carry current. Right? Full wave rectifier with diodes D1 and D2 is used to rectify 50 Hz alternating voltage. Then the diode D1 conducts dash number of times in 1 second. Very, very interesting question. Okay, good. D Sir Narendra. What is the answer for this question, Narendra? Is saying C. Okay, so here you remember that what is the input signal? Input signal, this is the AC. Full wave rectifier, this is the AC signal, and we know that this signal diode D1 conducts, this signal diode D2 conducts. Okay, and that's why output signal looks like this. This is the output signal. Right? Now, so diode, this is one signal. This is 1 Hz. Okay, how many Hz are there? Total 50 Hz are there. Okay, that means each second 50 times this thing is happening. Each second 50 times this thing is happening. That means each 50 times diode D1 is conducting once. Okay, each 50 times diode D1 is conducting once. That means the number of conduction happens in diode D1 is 50. Okay, the output frequency is 50 into 2, that is 100 Hz. In case of full wave rectifier, the output frequency is twice of the input frequency. The resistivity of a semiconductor at room temperature is in between. So again, this question came in 2025 in case of conductor and in 2022 in case of semiconductor. Same thing. Only difference is that here instead of meter they have given you centimeter. To centimeter to meter you have to multiply with 10 to the power of -3 to get the answer. Now as I mentioned, if you remember only one very simple thing for semiconductors, okay, thus resistivity is neither too high nor too low. Okay, if you see this one, okay, resistivity is very high. Okay, resistivity is very high. This is a insulator. Okay, plus means insulator. Okay, both of them are plus. Now here if you see that both of them are minus, that means resistivity is very low. So this must be, so this is insulator. This is conductor. Okay, because the resistivity is very low. This one is much higher than even this one. This one is also insulator. Okay, you don't need to remember any values, don't remember the values. Okay, convert the units, not required. You just understand the fact that insulators have very high resistivity, very low conductivity. Metals have very high conductivity, very low resistivity. Semiconductors are in between. So that means it will have one part negative, one part positive. In both cases, semiconductors will have one part negative, one part positive for resistivity as well as conductivity, both cases. So this must be representing the semiconductor. This must be representing the semiconductor. Okay, in 2025, same question was asked, along with the conductivity is also given, but for metals. Okay, so this is also very common repeating question. Okay guys, discuss about result tomorrow after your results are out. Okay, discuss about your results after results are out. Okay, most of you have joined us recently. If you have joined us before your board exam, then you should have scored, I can guarantee that you could have scored 90 plus, okay, in physics, because whatever I did in my class, okay, the exactly same questions came in the exam. The forbidden energy gap for germ, even in the morning before exam, I predicted, if you have seen that, even if you are going to fail, you could easily score 45 plus. Okay, from that one lecture, 30 minutes lecture, okay, so many questions came. Even my prediction about 5 marker question, my prediction about 2-3 marker questions, everything was correct. Okay. The forbidden energy gap for germanium crystal at 0 Kelvin is. Forbidden energy gap means the energy gap between the conduction band and the valence band. Okay, conduction band and the valence band. This is called energy gap, and that gap for germanium is 0.71 electron volt. That is for 0.71 electron volt. So correct answer is option D. And in our channel, we do not do 8-hour, 10-hour, 20-hour long marathons. I did only once, okay, for your MCQ sessions before your exam, but otherwise our sessions are not that huge, 2, 3, 4 hours maximum, and still that our prediction, our understanding was much better than many other people. They have done all the possible questions, but still their students struggled. Okay. Yes. Yes. Sir, what is your percentage in PU? Okay, when I gave my PU exam, my percentage was how much? 85%. Okay, 86% I got. Okay, and back then 86% was very good. My mathematics percent, I can tell you, was 90% plus. And my physics percent was 86%. Physics I got 86%, mathematics I got 92% or 93%. Chemistry was also 90%. My language was very bad. Okay, don't ask me my language percentage. So my language was overall not that good. I scored okay, not bad, but not that obviously 60%. In English I was really weak, so my English improved after I graduated. After I graduated, my English improved. So that during back in the day, my English was weak. I got less than 60%. In my vernacular language, I scored 60%, and overall I got 86%. Okay, anyway, all the best for your result tomorrow. I hope you will all break free and you will all score very good. Okay, and you will say that, sir, you all scored 90% plus. Don't worry if your result is not that good. Don't get disappointed. Okay, mishap happens in life, and that is very common. Okay, when I was a child, when I was studying in class, a nursery class, not nursery class, it was like upper KG or like that, I failed in mathematics. Okay, my very first exam, I written the exam, I failed in mathematics. Okay, I had no idea what is that. That is a innocence. Okay, when you appeared for your PO1 exam, some of you were careless, some of you were overconfident. Okay, so now what happened is that now your overconfidence level came down, your carelessness came down. You thought, okay, I will break the exam apart. Okay, I have cracked the code, and that code will change my life. So don't think anything, don't take anything taken for granted in life. Okay, so be it an exam, be it something important in your life, what is going to happen, don't take anything taken for granted. You have to work hard to achieve anything in life. Okay, without working hard, unless and until you are a son or a relative of Ambani and Adani, okay, they have a lot of money, or people like them, okay, those who have a lot of money in their pocket, okay, you have to work hard for everything else. If you are people of if you are belong to these people or people like them, definitely you will not be watching my YouTube lecture, right? You will have 10 different teachers teaching you from different sides all day long, right? So you will not be wasting your time with me in YouTube channel. So that is one thing. So you have to work hard in your life to achieve anything. Don't take anything for granted. If you don't work hard in life, then your results will be mediocre only. Okay, no matter where you go, whatever thing it is, not only exam. Okay, results are there in other things also. Okay, for in future you will go prepare for your interviews. Okay, if you are not prepared for the interviews, you will not get the job. And in fact, in future, as you are progressing, the job market will be slowly shrinking, because common jobs, okay, that is the people used to do an engineering, get a job in the IT company, those jobs will be reduced because of the obviously artificial intelligence. Now new jobs will be created in the field of artificial intelligence. Okay, so if you think that, okay, I will get into an engineering college, I will get whatever degree I will, and then I will move to IT, that kind of things are not going to happen. So you have to be careful in choosing jobs, in deciding your futures. Okay, so always be ready. This is the first step towards the future. So far you are still confined into your colleges, okay, where teachers are taking care of you, they are interacting you. Now once you move into engineering colleges, degree colleges, etc., your life will be open, nobody cares about you. Okay, you will realize that maybe one or two teachers, one or two people will care, otherwise nobody will care for you. Everyone will be, bro, do whatever you want. Okay, my job is to teach, my job is to take the class, I will do it and I will finish it. Okay, many areas it will be restricted to that only. Okay, your life will be open. Now if you are not controlling in that situation, if you go outside your common days, then it will be very difficult for you to come back, right? Okay, yes, thank you. Kathir Messi is saying, I did not get WhatsApp link to join Comet Kit 30 group to my phone number. Please reply. Karthik Messi, I will inform to the respective team, okay, that you have not received the message. If you have access to the course, okay, you can go and check the live chat. If the video will be available to you, the recorded lecture, there we have shared the WhatsApp joining link. If you go down somewhere around the presentation that we are doing, the last presentation page, okay, there was a WhatsApp link is given. You can manually type that out, or I will inform the team so that you will get the link. Okay, by the way, what is your registered name? If you mention that, I will be happy to help you. Messi, Karthik Messi. Sir, if I study for KCET masterstroke and practice 5 years PYQs, then how much can be my rank? So if you study from masterstroke and if you study 5 years KCET, okay, along with question practice is important. If you practice questions, because only preparation can get you around 100 marks, okay, only if you study. If you don't prepare in the practice test, if you don't take mock test, if you don't take time management, then what you will realize that at the end of the exam, I knew these questions, I knew the answers of these questions, but I did not get the time to finish the paper. Okay, that is one important thing that you have to realize. If you solve all the questions, that you will get the ingredients to score 140, 150 plus. Okay, that means you have all the things to cook the food, but you have to cook it within that time limit, right? 60 minutes plus 10 minutes to answer all those questions. Okay, even if you answer questions, there will be scramble to fill the OMR sheet. So you have to keep at least 10 minutes to fill the OMR sheet properly, calmly, so that you don't lose out any marks. After your OMR sheet is filled, if you still have left some time, then you solve a few more questions. So that is how you should do it. Okay, strategy, exam hall strategy will be discussed before exam, obviously not now, but anyway. So the main thing is that you can score 150 if you answer all the questions. If you can manage the time and answer the questions that you are supposed to answer, then 150 you can score. But without time management practice, that is difficult, because 60 questions, time will fly away like this. Okay, you are used to 2-hour, 3-hour exams in your board exams, in your college exams. 1-hour exams, time management is very, very difficult. Okay, and if you are preparing for that time management, then you will score 140, 150 plus marks. Okay. What is your Chetan fast forward? Why are you saying fast forward? No, Raftanjum, exam date is not changed. Exam date for your second attempt will be given to you from the student portal. You can check that out if they have uploaded the new dates. Otherwise, KCET exam dates have not changed. Okay, Kishore Varman. Okay, I will check Karthik. Kishore Varman. Narendra, I shared physics important chapters. Jasmine ma'am made a video of all the important chapters in PCMB. You go check that out, okay? All the lectures are done. Kishore Varman, I will inform the team, okay? Don't worry. In case there is a miss, I will let the team know about this. Okay? Thank you. Narendra, I told you already. Strava, it is over. You can see that our last slide is here. Lecture is over. Okay, that's why I was discussing. Lecture is over. Sir, in PCM, if I get 70% and if I get 160 in KCET, then I can get below 2000 rank. Okay, not difficult, not impossible. Yes, you can get. If you get 70%, that means 35. And 160 means about 80%, right? You can get. Yeah, I will send you mobile number next year. Raftanjum, it will be published by after a press conference. So they will generally do a press conference around 12 or 1 p.m. In the afternoon, and then they will announce that the portal will be open from 3 p.m. or 4 p.m. Okay, if I remember last year, they did a press conference from 12 and they said that the link will be activated from 3, but the server immediately crashed at 3. Students were able to check the results after 5 or 6. Okay, so we did a live at 5. after the results was we did a live at 6:30 because the paper students were not able to check the results, so we did a live at 6:30 because of that. So after 5 you should be able to check the results. So it will be a whole day tension, I know. Results will be out, how much I will score. Don't think too much about it, relax. It will be out only when it will be out. Okay, so relax, stay calm, stay cool, don't lose your focus on preparation of KCET. That is also important. Okay, that one day I know it will be gone because of this tension and anxiety. So stay strong. Okay, you know that whatever exam you have written, you know yourself, so the same result you will get tomorrow. Okay, so all the best guys. I will see you tomorrow.